This lesson deals with Supplemental Problem 2.2. You can find this problem in the ECE302 ebook in the Chapter 2 Supplemental Problem starting on page 3. We have two problems. First one has 3 ideal diodes, 4 resistors, and a battery. And can you find the current I and the voltage V? In the second problem, there are 3 ideal diodes, 3 resistors, but now 3 batteries. Likewise, can you find the voltage V and the current I? So here's problem A, and here's my 3 diodes, and here I've got 1 battery. Current has to come out of this terminal because this is the only source of power. Current would want to go this way, want to go this way, and want to go this way. With these directions, I would guess that D1 is a short, D2 is a short, and D3 is an open. If I were to think of these as resistors, and if current flows from anode to cathode, it's a short, and from cathode to anode, it's an open. This will be my first guess. And I'll label the currents for the diodes ID1, ID2, from anode to cathode, and then for the diode D3, from anode to cathode, the voltage VD3. I'm going to find the voltage V sub X here. So putting these two resistors in parallel, I get half the value, 250 ohms, and I form a voltage divider with 500 ohms and the 20 volts. 20 times 250 over 250 plus 500 is 6.667 volts. That's a voltage across here. Now I can use that to find my currents and voltages. Current in this diode would be the current that's in this resistor, which would be this node voltage minus this node voltage divided by 500. 20 volts, and this node voltage here is the value of V sub X, which is 6.667, divided by 500 is 26.67 milliamps, and that's greater than or equal to 0, so that's my first check for the guess for ID1. The current in ID2 is going to be the voltage across this resistor, which is V sub X, so 6.667 divided by 500, and that's 13.33 milliamps, and that too is greater than or equal to 0, so that guess also checks. And last, let's find the voltage across the diode D3. Now, since there's an open circuit, there's no current in here. The voltage across this resistor is going to be 0 times 500, which is 0, and then minus this node voltage, which is V sub X of 6.667. And that's a negative 6.667, and it is less than or equal to 0. That also verifies my guess. And lastly, let's find the voltage V, which is the voltage across here. Because of the open circuit, I have no current, and therefore no voltage. And the current I is the current in this resistor, which is the voltage V sub X divided by 500, and that's equal to 13.33 milliamps. Here's my second problem. I'm going to assume this is a practical problem. I'm going to assume that current comes out of the most positive power supply and goes into the most negative power supply. And what that's saying is that the most positive power supply is generating power, and the most negative power supply is also generating power. So if I do that, I would think that current would want to flow this way, and the current would want to flow this way. I'm going to guess that D1 is a short, and that D3 is a short, and because current's trying to flow this way, I would guess that D2 is an open. Again, we'll label the current from anode to cathode for our 2 on diodes, and then the voltage from anode to cathode for our off diode. Because I have a short circuit here, I have the 5 volts across this 2.5K resistor, just right across here. 5 divided by 2.5K is 2 milliamps. So I've got that current. Now what about the current in the resistor 3K and 7K? Well, the voltage across these 2 resistors would be the difference of these 2 node voltages. So this is 10 volts minus 0. So 10 volts divided by 3K plus 7K, or 10K, is 1 milliamp. 1 milliamp entering here. I have 2 milliamps leaving. I can do Kirchhoff's laws, or just think about it. 1 milliamp entering, 2 leaving. I got to have 1 more here. So that makes this equal to 1 milliamp. ID3 is greater than or equal to 0, so that checks. ID1 is this 1 milliamp current, and that's greater than or equal to 0, so that checks. And then lastly, what's the voltage across the diode? Well, it's going to be this node voltage, which is 5, minus this node voltage. And this node voltage, I know the current through this resistor is 1 milliamp, and the resistance is 7K, and this is short back to ground. That's 7 volts. That difference gives me minus 2 volts, and so that does check also, that the voltage across the open circuit is less than or equal to 0. And lastly, we've got to find the current I and the voltage V. The current I is the value of ID1, which is 1 milliamp, and the voltage V is really the voltage across the 7K resistor. We just found that to be 7 volts. And this is Supplemental Problem 2.2.